Again, welcome to Statistics with Microsoft Excel. In these lectures, we're going to discuss about data and statistics. This is our Unit 1 lecture. So our main objective is to go through the definition of statistics and also data and data sources. Also, we're going to discuss about the two branches of statistics, which is descriptive and inferential statistics. Also, how we can use Microsoft Excel in analyzing our data. So first we start with what is statistics. So we know statistics can also refer to the art and science of collecting, analyzing, presenting, and interpreting data. So the whole concept of a statistics is a branch of mathematics that deal with, again, collecting the methods we can use to collect data, analyze the data, and also presenting the data. If we get a result, we're going to interpret the result. So the term statistics can refer to numerical facts such as averages, medians, percentage, and maxima that can help us understand a variety of business and economic situations. And there are so many applications of statistics. An example can be in the public health and epidemiology. And normally public health professionals can analyze medical data or biological data, or also clinical data to find the patterns in the data. An example with epidemiologists basically can analyze the data to find, again, the exposure and outcome. What are the risk factors for a specific disease? In accounting field, again, public accounting firms use statistics concept to conduct audits for their clients. In economics, economists also can use statistics concept in making a forecast about the future of the economy or some aspect of it. In finance, again, financial advisors can use price earning ratios and dividend yields to guide their investment advice. So in all these professional fields, again, statistics concepts are used, which is collecting data, be able to prepare the data, then analyze the data, then also get a decision from the process of analyzing the data. So data and data sets. So the definition of a data is that data are the facts and figures that is collected, analyzed, and summarized for presentation and interpretation. A data can be an audio, can be a text, can be values, can even be a video. So data have facts and figures that we collect. We can analyze it, summarize for, again, presentation and interpretation. All the data collected in a particular study are referred to as a data set for the study. So for example, we can have a data set for a DNA patient's DNA data set. And we can use this data set to analyze the patient's DNA to find a specific functions or disease, whatever we need. So there are some elements and variables and observations. When we discuss about statistics, these are some few terms that we can come across, which is element, variables, and observation. So elements are entities on which data are collected. So elements are the entities on which data are collected. So example of an element can be a patient or can be a customer. Then a variable will be the characteristics of interest for the elements. So in terms of a customer element, one of the characteristics can be customer last name or customer address. So these will be variables. And the set of a measurement obtained for a particular element is called an observation. In statistics, again, a record can be called an observation. So what we mean by set of a measurement will be, for example, we have one customer in Amazon data set or database system. The customer last name, first name, address, amount of money spent, purchasing, etc. This will be an observation. So a set of measurements. These are all the measurements: last name, first name, address, obtained for a particular element is called observation. A data set with n elements contains n observations. So example, a data set with 100 customers, we said it contains 100 observations. Also, the total number of data values in a complete data set is the number of elements multiplied by the number of variables. Because each element, let's say each customer may have 100 variables or 10 variables. So a customer have 10 variables: last name, first name, address, up to 10 variables. Now, the total number of data values in a complete data set is how many customers we have. We multiply by the number of variables each customer have. So we have an example here of what is variables. So this will be our data set. Everything here is our data set. So in this data set, we have 5 elements, element names. This element, a variable name is nation. So the variable name is nation, WTO status, per capita GDP, and Finch rating. So this will be variables. The elements are the content. So Armenia, member 3615BB Manus. This will be one observation or one element. So the element names and also the whole concept here, all the items we have here is called a data set. Now we can see that in this our data set, we have names and also we have values. So in statistics, we have different level of measurement. This is scale of measurement. And normally we have what we call the nominal, ordinal, interval, and ratio. So a nominal will be a regular test or names. For example, the nation, Armenia, or customer last name, Williams. These are names. True, false, yes, no. These are all nominal. We cannot do any calculations on them. The only calculations we can do on nominal data set is by counting. The next is the ordinal. Ordinal came from the word order. So any data set or any items that we can put in order, the level of measurement will be ordinal. So example would be, we have a baseball league, US baseball league. The first team, Yankees first, LA Dodgers second, Boston third, etc. So these are in order. Or the grading system. In our school, we have A, B, C, and D. This is in order. Or a customer smokes cigarette, light smoker, medium smoker, heavy smoker. These are all in order. So any data values that are in order. So the only arithmetic operation we can perform on ordinal data will be greater than or less than, which we call the relational operators. So I can say the first is greater than second, or second is less than first, etc. Then next is the interval. And the interval is values. So sometimes we use the term quantitative values. We can do at least addition, subtraction, and also we can do everything that nominal and ordinal can do. We can also do at interval. So counting, less than, greater than. Ratio also is values, but the difference between interval and ratio is, example will be the temperature. The temperature of a weather can be 0. 0 means it's very cold. So temperature cannot be a ratio. Example of a ratio will be account balance. If we say account balance is 0, it means there's nothing. But when we say temperature is 0, it means it's very cold. So in interval, 0 means something. In ratio, 0 means nothing. And in ratio, we can do almost every arithmetic operations. So here we say the scale determines the amount of information contained in the data. And also the scale will indicate the data summarization and also the analysis that are most appropriate. So for example, if I have a nominal data, I cannot find the average value of a nominal data. We can say a customer name, we have 10 customers with different names. We want to find the average of the names. We cannot, but we can count how many customers have the same name or how many customers from a specific city or a country. Same thing applies to a ratio. In a ratio value, yes, we can find the average, we can find the mean, we can find the count. So that's why we say the scale of measurement will indicate the type of operation we can perform on the data. So we start with the nominal again. Nominal are labels or names used to identify an attribute of the element. So again, we cannot do arithmetic operations. So this would be a non-numeric label or numeric code. When we say a numeric code, it would be, example would be like zip code. We cannot say a zip code of Brooklyn neighborhood 11226 plus the zip code of Texas neighborhood 1045. No, we cannot add two zip code. Or employee ID, we cannot add two employee ID. So even it's a numeric, but it's a code. So we cannot perform any arithmetic operation. So a nominal again is a data that are labels or names or a code, a numeric code. We cannot perform arithmetic operation. The only arithmetic operation we can perform is counting. So an example here is that the WTO status category for the nations. In our previous example, we saw the data set. It used the non-numerical labels. For example, whether you're a member of WTO or you are not a member or you are an observer of WTO. So a member or observer or not a member, we cannot do any arithmetic operation except by counting. Then next we go to the ordinal. Again, ordinal, we said it came from the word in order. So something in a ranking order. So data have the properties of nominal data. So it still have the property of nominal data. But also we can put it in order or rank of the data is meaningful. So it's still a non-numeric label or numeric code may be used. For example, grade A, grade B, grade C, etc. So an example with our previous data set, the WTO, here we say that the non-numeric rating labels from AAA to F is used for Finch rating. This is for credit rating. So AAA means you have the nation have a good credit. F means it has a bad credit. Then between AAA to F, we have some others. The next is the interval. Here we say the data have the properties of ordinal data also. We can put it in order. For example, a temperature can be 30 degrees means it's more warmer than 20 degrees. 20 degrees is more colder than 30 degrees. So it's in order. But at the same time, the interval between the observation is expressed in terms of a fixed unit of measurement. So I'm using degrees here. We can use other kilogram, other measurement. The interval data are always again numeric. So with interval, we cannot use names like nominal or ordinal. Interval always have to be values, numeric. So an example would be Melissa has an SAT score of 1985. So Melissa has a SAT score of 1985, while Kevin has SAT score of 1880. So this is interval values. So Melissa scored 105 points more than Kevin. They are in order. A ratio is almost similar to interval, but also it has a property of interval, a ratio. A ratio means two values is meaningful. So we know, like in mathematics, college algebra, a ratio means you have two values. One is numerator, then the other one is denominator. And that's the concept when we say ratio in college algebra. It means it has numerator and denominator values, two values dividing. Then when we say proportion, it means ratio multiplied by another ratio. But in statistics, this ratio represents a numeric value that we can do all arithmetic operation, whether addition, subtraction, multiplication, and division, everything. So the data have all the properties of interval data, and the ratio of two values is meaningful. So division is possible. Variables such as distance, height, weight, and time use the ratio scale. And this scale must contain a zero value that indicating that nothing exists for the variable. So for example, if we say the person weight is 0, it means the person don't even exist. Or if an object weight is 0, it means it doesn't exist. But when we say temperature is 0, it means it's very cold. So that's not ratio, but rather interval. So example of a ratio here, we say Melissa's college record shows 36 credit hours N, while Kevin's record shows 72 credit hours N. So Kevin again has twice as many credit hours N as Melissa. Now, data can be organized in two forms, either categorical or quantitative data. Sometimes the term categorical also we use qualitative. So most of the time we will see quantitative and qualitative. Qualitative means the data we can perform an arithmetic operation. Quantitative means it's a numerical data we can perform arithmetic or analyze it. So data can be further classified as being categorical or quantitative. Again, the term categorical, we can also use qualitative. So in statistics analysis, we say that is appropriate. That is appropriate depends on whether the data for the variable is categorical or quantitative. And we may go detail about this in the future lectures. For example, if we have a data that is categorical, we use different hypothesis techniques to analyze it. If it's a quantitative, we use a different techniques to analyze it. So if I have a categorical data, I cannot test the mean. There's no mean. Maybe there's a proportion, I can test the proportion, or in terms of the mode, count, etc. So categorical data can be labels or names, as we said. So categorical data is almost the same as nominal data. So as we said earlier, it's often referred to as a qualitative data, categorical. So you can either use nominal or ordinal scale of measurement, and that's qualitative. It can be either numeric or non-numeric. As we saw example of a zip code or employee ID is categorical data, that is numeric. Then quantitative data, the data will indicate how many or how much. So we have two types, discrete. Discrete quantitative data is based again on measuring. The measuring is based on counting. So we say discrete if measuring how many. So you can see that the discrete data will not have a decimal value. So for example, how many patients a doctor saw today. We cannot say the doctor saw 22.6 patients, no. So discrete have to be a whole number, it's based on counting. The doctor saw 20 patients today, 5 patients today. Now, continuous is based on measurement. So, for example, a height. or a weight of a patient, it can be 20.6 kilogram. So again, we may go detailed by this when we study probability. We have a discrete probability distribution. We have continuous probability distribution. The difference is that the variable, the random variable, either is based on counting, then it's discrete. If it's based on measurement, then it's continuous. So quantitative data are always numeric. We can perform any arithmetic operation. So these are all the scales of measurement. So we start with the data. We have two types of data, the categorical or qualitative. Then we have the quantitative. Then within the categorical, we also have numeric and non-numeric. Numeric can be like zip code. Again, we cannot perform arithmetic operation on zip code or social security number. It's a numeric categorical data. Now, within the numeric categorical data and non-numeric, we have the level of measurement, the nominal and ordinal. Non-numeric also is always nominal and ordinal. So with categorical data, all of the level of measurement are only nominal and ordinal. Then when we come to quantitative, this is only numeric values. We can perform arithmetic operation. So they are all numeric and they can be either interval or ratio. Now we say the difference between interval and ratio is that with interval, 0 means something. With ratio, 0 means nothing. With ratio, we can divide. So in college algebra, we know a ratio means we have a value divided by another value. A ratio will be like a fraction. We have 1/2 or 3/7. That's a ratio. So we also have what we call the cross-sectional data in statistics. When we say a cross-sectional data in statistics, we are trying to say that we collected the data at a particular point in time, not during the duration. For example, I can collect the data about, let's say, a customer buying behavior within 10 years or 2 years. Or I can collect the data about a patient that come to the hospital, we monitor his blood pressure within 5 years. This is called a time series data. I collect the data from one single patient, monitor his blood pressure for 6 months or even for 1 week. It's a period of time, so it's a time series data. Cross-sectional data means I will collect the patient data at a particular point in time. Today at 2 p.m., I collect the patient's blood pressure. I'm not going to compare it with tomorrow or other time. So a cross-sectional data are collected at the same or approximately the same point in time. So example given here is that data detailing different variables like status, per capita GDP. This is the example we saw for the WTO nations. This data are collected at the same point in time. For example, the GDP for a particular country was collected at a particular time. Now, we also have time series data. So we say time series data are collected over several time periods. So example, US average price per gallon of conventional regular gasoline between 2012 and 2008. We can have that. So graph of time series help analyze understanding. Also with the blood pressure or a patient, any condition of a patient, we can collect the data within some period of time. If we are giving the patient, let's say a medicine or some intervention, we can monitor the progress of the patient. So that will be a time series data. So what happened in the past, identifying the trends over time, and also we can project the future condition of the patients. So this is a graph of time series data. This data is measured by date. So the time period is daily or monthly. It can be yearly, weekly, etc. Then here we want to know the average price per gallon. So we can see the average price per gallon from January 12 to, let's say, January 18. We can monitor it. Again, it can be any period of time. Here is daily or weekly. It can be seconds, minutes, hourly, yearly, etc. But time series is a data that we collect within some period of time. A very common time series data will be monitoring a patient heart function. Blood pressure is common in medical field. In business field, let's say stock price. Stock price is time series. Prices changes according to the time conditions going. So where do we get data from? We can get data from many sources. Example will be the internal company records, business database services, government agencies, industrial associations, special interest organizations, and of course the internet. And there are so many sources. Most of all these data again will be online. So data available from internal company records can be employee records, productions if the company is producing, manufacturing products, or inventory records, sales record, credit record for customers, and of course customer profile. This can be different types of data from a company operation. Also, data available from selected government agencies. Almost every government agencies may have a data. So Census Bureau, Federal Reserve Board, Office of Management and Budget. Example would be a CDC, Center for Disease Control, Bureau of Labors, data.gov. Actually, data.gov have so many different types of data from different government agencies. For example, agricultural, consumer education, health, manufacturer data. And data sources, again, can come from most of the time when we are doing a research or a studies. So in statistical studies, we have observational studies. Here in observational study, we are going, no attempt is made to control or influence the variable of interest. So in observational studies, I'm going to collect the data, maybe a sample based on the observation. I'm observing the subjects and I'll collect the data. There's no any intervention. We are not going to monitor or manipulate any data. But sometimes we have something we call the Alton effect. Alton effect. Sometimes when the subjects know that they are being studied or observed, maybe they can change their behavior. So an example of an observational study is researchers observing randomly selected group of customers that enter Walmart supercenter to collect data on variables. And data sources, another concept is experimental. Here we can manipulate the variable. We can give intervention control. So an experiment normally will happen in a lab. If it's a biological experiment, biological lab, or any type of lab. So here we say the variable of interest is first identified. Then one or more variables are identified and controlled so that data can be obtained about how they influence the variable of interest. The goal again here is that we are trying to find some exposure and outcome. The environment, what effect, what will be the result. So this is experiment. Again, we'll go more detail on this in the future lectures. Data acquisition consideration. Again, when we are collecting a data, I think most important is the time requirement. So searching for information can be time consuming, especially online, even second. We have two types of data. Primary data means a data that is generated during a research. Then secondary data is a data that has already been used. And these data are in a computer system or online. These are the data that is time consuming to get, especially as we know now, there are so many data generators, big data analysis, so many. Also, cost of acquisition. Organizations often charge for information, even when it is not their primary business activity. These issues, we have these issues for many years, let's say 20, 30 years ago. In US, again, we have a bill that was passed about this issue. third party collecting the data, then sell it to a third party company is now an offense. Also, there can be a data errors using any data that happen to be available or were acquired with later care, and there may be errors inside. Normally, we use the term noisy, or there will be a missing values in the whole data set, and this can give us misleading information. Now, we have two types of statistics: descriptive statistics. Here, most of the statistics information in the newspaper, magazine, company reports, and other publication consists of data that are summarized and presented. So in descriptive statistics, the whole concept is that we are going to not to get decision from the data, but rather descriptive statistics talks about how we can organize our data, either by using graphical or tabular form. Then later, we try to explore the data to understand the data. So for example, we can find the central tendency, what is the average, the mode, the median, or the location of 25%, 50%. Here we find the quartiles. So descriptive statistics concept is to understand your data. The goal is to explore the data to understand it, organize the data. Then we talk about inferential statistics. This is the most important part of statistics. Here we are going to collect a sample. Then we are going to use the sample to make a decision on the population, because collecting data from the whole population is a time consuming, and most of the time it's impossible. If I want to do a study in New York City, the population is over 12 million. I may collect maybe only 1,000 sample, then I'll test the sample. The decision I will make or the result I will get from the sample, I will apply it to the population. So here we need to be very careful that we are going to reduce the bias if we cannot remove it. And we may again discuss detail about this. So this is a process of, again, start inferential. For example, step one, I have a population consists of tune-ups. Let's say this is a mechanic workshop. Average cost of parts is unknown. So what I'll do, I'll take a sample of 50 engine tune-ups, which is examined. Then the sample data provide a sample average parts cost to be 79. Okay, so now if I know the sample of 50 said 79, then I'm going to apply this 79 to the whole population, because maybe the population here will be over 1 million, and I can't take the whole data of 1 million and find the average. So I take a sample of only 50, find the average, then apply that to the whole population. Now, this is our main tool we are going to use in this course, which is Microsoft Excel. So today, statisticians and data analysis normally use a computer software to do their job, to perform the computation. So many of the data sets in this course we are going to study, again, we need, it's a very large data set, so we need at least a software application. In this course, we're going to use Microsoft Excel. Then also Excel have what we call the hardening, data analysis or stat tools, which we can download. Again, we will go through these steps, how to do this. So let's just talk a few things about Microsoft Excel. In Microsoft Excel, we can enter data into the cell. Normally, we will call this the cells. So when we enter our data, we can perform a formulas. So if I'm using Excel, the first thing I'll do, I'll open Excel, workbook, we call it workbook. I'm going to enter data. Then whatever, let's say I'm looking the average of the values, then I can enter a formula or use the functions. So we can use the tools to apply the functions. Then the computer will do the work for us. So this is an example of an Excel worksheet. Normally in the columns, we have A, B, C, D. The rows is 1, 2, 3. The intersection of a row and column is called the cells. So for example, and the cells have a name. The column name comes first before the row. So let's say where I have $91, the parts cost $91. The cell name is C2 because it's in column C and row 2. Then after that, again, we enter the values finish, we can enter the Excel formula worksheet. So here I'm looking for the average parts cost. So I have the function name is average, C2 to C51. This means the range from the values in cell C2 to cell C51. Normally, when we are entering the formula, we don't use the values, we use the cell name. The reason is that if you use the cell name, when you change the values in the cells, the Excel will automatically give us the new answer. But when you use the value in the formula, if you change the value, Excel cannot do anything, cannot change it. The answer cannot be changed. So always we use the cell name in the formula so that when we change the values in the cells, Excel will automatically change the name. So we click enter, then we get the result. So in analytics, we have 3 types of analytics, which in statistics we're going to cover. Descriptive analysis means we are using a technique that will describe what happened in the past. Predictive analysis means we are going to use analytical techniques that will tell us what will happen in the future. So it's for prediction. Then we have prescriptive analysis. Prescriptive analysis is analytical techniques that will use a best course of action to take. So these are the major 3 types of analytics. Descriptive analysis is analytical techniques that describe what happened in the past. Predictive analysis, analytical techniques that use models constructed from past data to predict future. And prescriptive analysis will yield the best course of action to take. So again, this will be the conclusion of our lectures. And in the next lectures, again, we will go more details with using the Microsoft Excel for this course. So again, wish everybody the best and thank you.